All right, today we're gonna be looking at the nature of the roots of a quadratic equation. And on the board, I've written two formulas. The first one in black, which is known as the quadratic formula. X is equals to minus b plus or minus square root of b squared minus 4ac over 2a, right? And inside of the square root, I circled in green the b squared minus 4ac. That b squared minus 4ac, we call it delta. We call it delta. All right. This is the symbol for delta. So is delta is equal to b squared minus 4ac. Right. So the b squared minus 4ac is also known as delta. Also known as delta, which is b squared minus 4ac. This delta um gives us the nature of the roots of a quadratic equation, right? Yes, so the nature of the roots of a quadratic equation depends on the value of delta. Depends on the value of the delta. And the value of the delta is b squared minus 4ac. All right, so I had to explain that so that you know that the delta gives us the nature of the roots of a quadratic equation. All right. So the roots or solutions, roots is also known as solutions, all right? Then the roots or the solutions of a quadratic equation can be real or non-real. All right. So what I'm saying here is that the roots of a quadratic equation, which is also known as the solutions. So when I say solutions, I mean roots. When I say roots, I mean solutions. So the roots or solutions can either be real or non-real. Can either be real or non-real. This is very, very important to take note of. Can be real or non-real. All right? And the solutions can either be equal or unequal. Or unequal. All right? Then roots also can be rational or irrational. Okay. So what I'm trying to say is that the real and or a non-real, equal or unequal, rational or irrational. This is what we call the nature of roots. The nature of roots. The nature of roots. The nature of roots is what I mean. All right. So for me to be able to find the nature of these roots, whether they are real or non-real, equal or unequal, rational or irrational, I apply these two formulas that I wrote on the board. The first one, which is the quadratic formula, and the other one, which is the delta. All right. However, before doing this, let us bear the following in mind. Let us bear the following in mind that a square root of a negative number, okay? Square root of a negative number is non-real. It's non-real. It's non-real. All right. For example, If I say square root of -4, all right, this is non-real. Then square root of a perfect square, square root of a perfect square, that's what I'm writing short there. Square root of a perfect square is real. We all know that. It is also rational. Okay, for example, square root of 4 is equal to 2. So you can see this is real and also rational. All right. Okay, then let's go to when we square root a non-perfect square. A non-perfect square. Non-perfect square. It's gonna be real, but irrational. But irrational. For example, root 3. Square root of 3. Okay. So now let's look at some different cases that we're going to use as examples. All right, so I'm going to use case 1. I'm going to use case 1 as an example. And maybe I want to touch on 2 more cases. Let's see. So case 1 is got x squared minus 3x plus 4 is equal to 0. So what I want to do is here to find the roots and also the nature of roots. All right. I want to find the roots and the nature of roots using um, the quadratic formula. All right. And the delta. All right. So first things first, what I need to do is I need to check whether this quadratic equation is in the standard form. What do I mean by standard form? This is the standard form. Ax squared plus bx plus c is equal to 0. Is equal to 0. All right. So this is what we call the standard form of a quadratic equation. So you can actually see that the quadratic equation is in its standard form. Then I find my a. So what is my a? My a is the coefficient of x squared, which happens to be 1. Well, there's a 1 here. So then I come here and I write a is equal to 1. Then b is the coefficient of x. You can see that here. B is the coefficient of x, and which happens to be -3 here. So I'm just gonna come and write b is equals to -3. Then my c is 4. Then I'm gonna write 4. Okay, so after doing this, what am I gonna do? I'm going to impute the values of a, b, c into the quadratic formula. All right, into the quadratic formula. I'm gonna rewrite the quadratic formula, which you must know by head if you are a student that I teach. You have to know this by head. X is equals to minus b plus or minus square root of delta, which is b squared, minus 4ac. Remember that the b squared minus 4ac is what we call delta, then over 2a. Okay, so now let's impute the values of a, b, c into this quadratic formula. Right, so if I'm to impute this into the quadratic formula, this is what I'm gonna get. X is equal to minus, and then minus 3 That's our B. Plus or minus square root. Our B is minus 3, remember? So I'm going to just come here and write minus 3 squared. Minus 4. What is our A? Our A is 1. I'm going to put 1 here. Our C is 4. Then I'm going to put 4 there. Okay. Right. Then over 2A. Then 2 times 1 because A is 1. Right. Then this then simplifies to X is equal to 3 plus or minus root negative 7 over 2A. Okay, let's wait a minute. This negative 7, remember I say this is our delta. So this is delta. Our delta is equals to negative 7. All right. Our delta is equals to negative 7. All right. Let's see if I wanted to use the formula for delta, would I get negative 7? Yes. Okay, let's see. Let's see if I was going to get negative 7. So what is the formula? It's delta is equal to b squared minus 4ac. Let me see if I'm going to get that same value of negative 7. All right, so what I'm just going to do is I'm going to still impute these values of a, b, and c into this formula of delta. All right, so this becomes delta is equal to negative 3 squared minus 4 times 1, because a is 1, then c is 4. So therefore, delta will be equal to negative 7. If you simplify it, you still get negative 7. You see that? You see that? Yeah. And you can see that negative 7 is less than 0. Negative 7 is less than 0. So if delta, if delta is less than 0, what does that mean? It means the nature of roots are going to be non-real. All right, it's going to be non-real. Yes, it's going to be non-real because if delta is less than 0, then the nature of roots are going to be non-real. All right, so anyway, let's finish um, our quadratic equation that we were solving using the quadratic formula. So we were right here. So let's finish it up. Let's finish it up. Let's continue. So we had x is equal to 3 plus or minus square root of negative 7 over 2. Okay? Because we said 2 times a, which is 1, a is 1, so it's 2 times 1, it becomes 2. Okay. So which we then conclude and say this is going to be the answer, right? Just leave it like this. All right, let's look at another example. Let's look at another example, which I'm going to call case 2. I'm going to call it case 2. All right, so case 2 is x squared minus 6x plus 9 is equal to 0. All right. So I want to find the roots, whether they're equal or not, and also I need to find the nature of those roots, whether they are rational, irrational. So what I'm going to do is I'm going to use the quadratic formula. First things first, check if it's in the quadratic form. Yes, it is. So I need to find my A. My A is 1. My B is -6. Then my C is equal to 9. So what am I going to do next? I'm going to impute these values of A, B, and C into the quadratic formula. So if I impute them, it will be like this. X is equal to a negative, open brackets, -6 plus or minus square root. Remember, what is inside the square root is our delta. Remember that? So -6 squared -4 times 1 times 9. Okay, so this is our delta. So the answer we are going to get here by simplifying what I'm circling here is going to be our delta. All right, so let's continue. So this is going to be equal to a minus and a minus, that becomes a positive. So this is going to be a +6 plus or minus. Then if you simplify the -6 squared -4 times 1 times 9, it's going to be 0, by the way. So this is going to be square root of 0. Oops. So that means our delta is going to be 0. That's what it means. Our delta is going to be 0. Then over 2, right? Which then simplifies to 6 plus or minus square root of 0 is 0. Then over 2. All right. So therefore, my two values of x, which I'm going to compare and see whether they are equal. So the first one, I'll check it when it's a positive. So I'm going to take the positive and say 6 plus 0 over 2. Okay, so you can see here that x is going to be 3. X is going to be 3. And then when I put a negative, so it's going to be 6 minus 0, then over 2, which 2 gives me 3, which gives me 3. So that means these roots are equal. You can see that the roots are equal, right? The roots are equal. Okay, so now I know that the roots are equal. Now let's find the nature of the roots. I already know that the roots are equal. Now I want to know whether it's going to be real or irrational. So what do? I use the value of delta. All right, I already know that delta is going to be 0, by the way. Yeah, because when we simplified, we got 0 right here. There. See where I'm putting the arrows? So I already know that delta is 0. All right, but just to prove that delta is going to be 0, I'm going to use uh, the formula delta is equal to b squared minus 4ac. Then look at this now. I'm going to impute my values of a and b and c, the ones that I got right there. These are the values that I'm going to impute. Then let's see if we're going to get 0. So if you impute, this is going to be delta is equal to -6 squared minus 4 times 1 times 9. Okay, which then becomes 0. All right, so delta is 0. So when delta is 0, what does it mean? When delta is 0, when delta is 0, it means the nature of roots are real. When delta is 0, the nature of roots are real, rational, okay? It means they are real and they are rational. And we have already found that here the roots are equal here. So we can then also add that they are also equal. Also equal. All right. So I'm done. I have found the nature of the roots. All right, let's go to case number 3. Let's look at case number 3. Case number 3. Case number 3. So case number 3 is x squared minus 5x minus 6 is equal to 0. All right, so I'm going to find my A, my B, and my C first. So A is a positive 1, B is a negative 5, then C is a negative 6. Then I'm going to impute these values of A, B, C in the quadratic formula in order to see whether the roots are equal or not. All right, so I'm going to impute them now. So this is going to be x is equal to minus, open brackets, minus 5 here plus or minus square root of minus 5 squared minus 4 times 1 times minus 6. So always remember that this is our delta. This is our delta. The value we get when we simplify this is going to be our delta. Never forget that. So over 2 times 1. All right, so this then simplifies to x is equal to 5. This is going to be 5, but the minus and the minus becomes a positive 5. And then this is plus or minus square root of 49. So yeah, this 49 here is our delta. The 49 there is our delta. And 2 times 1 is 2. So I already know what my delta is. My delta is 49. My delta is 49, which I'm going to confirm by using the delta formula and see whether it is indeed 49. But I can already see that the delta is 49. And then 49 is greater than 0 and 49 is a perfect square. But I'm going to conclude later on. But first things first, let's find out if the roots are equal or not by using the quadratic formula. So let's continue. X is going to be equal to um, square root of 49 is 7. So this is going to be 5 there plus or minus 7 over 2. Okay, so therefore the two values of my X, which I'm going to compare and see whether they are equal or not, they're going to be like this. So first I'm going to take it when it's positive. Or I'm going to take it when it is negative. Okay, so here, what is going to be my X equal to? Well, here my X is going to be equal to 6. Yeah. Then here, what is my X going to be equal to? My X is going to be equal to a negative 1. So are the roots equal? No, the roots are not equal. The roots are not equal. Okay, so I've found out that my roots are unequal. So now I need to determine whether they are real or rational using the delta value. Okay, so I already know that the roots are unequal. So now let's use the delta form or formula, which is delta is equals to b squared minus 4ac. Okay, so if I sub in my a, my b, and my c, which I found here, right there, these ones, these are the values that I'm going to impute in the delta formula and see whether I'm going to get 49. Yeah, remember when I circled here, then I say this is going to be our delta. That's what I just want to find out, if it's going to give us 49 if I impute the values into the delta formula. So this becomes delta is equals to my b. My b is a negative 5. So here I'm going to put negative 5 squared minus 4 times 1. And my c is negative 6. Right? Which, of course, if you simplify, you can actually see that it's 49. It's 49. And 49 is greater than 0. So 49 is greater than 0. And we know that 49, which happens to be our delta, is also a perfect square. It's a perfect square. 49 is a perfect square. Okay. So if delta is greater than 0 and delta is a perfect square, if delta is greater than 0 and delta is a perfect square, that simply means that the nature of roots are real. They are rational. Why? Because 49 is a perfect square, so it's going to be rational. And also, we found out that the roots are unequal here. All right? Yeah. then we then conclude that they are also unequal. They are also unequal. Okay, so um, we are done. We are done. So let's just conclude by looking at the nature of the roots of a quadratic equation. So we say that when delta is less than 0, for example, if it's a negative number, this means it's non-real. It's non-real. It's non-real. All right. And when delta is equal to 0, and delta is equal to 0, it means the nature of roots are real and rational and equal. All right. What if delta, what if delta is greater than 0, and then delta is a perfect square? And delta is a perfect square? It simply means that the nature of roots are gonna be real, gonna be rational, and unequal. Okay? What if delta is greater than 0, whereas the delta is non-perfect square? Is non-perfect square. That's in short. So what does that mean? It means it's real, the nature of roots are real, irrational, because it's a non-perfect square, so it's gonna be irrational. And then the roots are going to be unequal. Okay, all right. So that's basically it. Um, just find one or two questions that you can attempt and apply the steps that we were taking. First, you find whether the roots are equal or not equal by using the quadratic formula. Then after you are done, you then use the delta formula to find whether they are real or rational or real or irrational. All right, cheers. Bye-bye.